This is the first presentation on this class, which is Object-Oriented PHP. PHP was not originally created to be an object-oriented language. The first time any objects were available at all in PHP started with the first PHP 5 release back in 2004. PHP, I think, would be more accurately described as an object-capable language instead of an object-oriented language. There are more true object-oriented languages like Java. PHP is not that way. The objects are an add-on. So you may use objects with PHP, but you obviously don't have to. Even with objects in PHP, we're going to have to use a little bit of procedural code to get things to run. This class is going to introduce you to nearly all of the PHP object-oriented constructs that you're going to need. There will be a lot of video demonstrations given, where you'll see the code, I'll run the code, and the code will be explained in some detail. A little bit about me. I started working full-time in information technology all the way back in 1977 as a mainframe COBOL programmer. Moved into Windows programming and database technologies in 1994 and started web development in 1997. I became a full-time instructor at a community college in California in 2001. And have taught for a number of colleges and universities part-time as well as doing corporate training and training for Infinite Skills. The subjects that I teach are PHP, Java, JavaScript with jQuery, Ajax technology, and Oracle SQL, MySQL, and the standard HTML, CSS information, and even just a little bit of Perl from time to time. I have a master's in education with an emphasis on teaching adults in online settings. That's from the University of Phoenix in 2004, and my bachelor's degree is in mathematics from Illinois Institute of Technology in Chicago, all the way back in 1978. But truly, my real education has been on the job and doing teaching. There is no better way to learn than to teach. This presentation is on what is object-oriented programming. Not just object-oriented programming for PHP, but object-oriented programming in general. The key thing is, surprise, surprise, objects. Now, what is an object? An object is going to be a holder for all the variables and logic that we would use in a program. In procedural PHP, it's standalone code. We define a function, we call a function, we set a variable equal to something. We're not going to do much of that in the object-oriented PHP or object-oriented programming at all. All of the logic and variables will live inside of these objects. Objects contain related variables and functions. And by related, this is a logical concept. We're going to put things together that make sense to be together. I'll have some examples later. Some of the key concepts are encapsulation, inheritance, and something called polymorphism. I have encapsulation and inheritance highlighted here because they're what we're going to cover in this class. Polymorphism is not implemented very well in PHP, especially as compared to other languages like Java, and it's rarely used. The key concepts of encapsulation are going to be what we set up here. We're going to try to keep logic and variables together, things that are related to each other. The other concept is something called inheritance. This allows us to put things at a high level of abstraction in our program and inherit down methods and variables we might need in a lower end of abstraction. Basically, it's like one function inheriting properties and logic from another function, and you'll see more of this as we go on. Here's some key terminology. Getting used to this is half the battle, but all of these concepts that I'm going to talk about are going to be introduced again and again throughout all of the presentations that I'll give with code. Functions are defined inside of an object. In object-oriented speak, they are called methods. I'll use the terms interchangeably. For all practical purposes, functions and methods are the same thing. Variables can be defined within an object and not inside a function. Those variables are called properties of an object. Sometimes they're called attributes, and there are a few other synonyms, but conceptually they're properties of the object. An object is built based on something. It's built, or the key word here is instantiated, from a class. Now, a class is something that defines what is contained in an object, the various properties, the various methods or functions that are in an object. The class will serve as a definition of how to build an object. A class can inherit properties and methods from another class. An abstract class can be inherited by another class, but it cannot be instantiated by itself. More on that later. An interface is another key thing that we're going to build with object-oriented programming. It's a special object, if you will, that can contain constants and method definitions. Not methods with code or anything, but the method definitions. And these are implemented. That's a key word. They're implemented by other classes. Now, if you're thinking to yourself, oh boy, I didn't understand any of that. This is just your first pass at seeing these words. They're important to know as we learn object-oriented programming. For those of you who have programmed in other languages, like Java, that are object-oriented, they'll be familiar to you. Let's look at this and make this a little bit simpler. This is an easier way to think about object-oriented programming. This is my definition. Objects are defined by a meaningful name. We give something a name, and that name is used to keep related functions and variables together in one place. Here's kind of a conceptual example. A payroll object might contain a variable that holds a check number for a check we're going to write, and it might hold a function that would calculate the withholding tax on a paycheck. This is a function about payroll. The variable, or a property, is a check number. That's something about payroll. So things that go together. Conceptually here, we wouldn't refer to check number as a variable all by itself. It would be payroll, and then an arrow here to say the check number that's on the payroll object. Or over here, the method or function, the calc withholding tax function, is on the payroll object. So we'll be doing a version of this when we code to say where the variable or the function lives. We won't just put these by themselves as we do in procedural PHP. What's missing in PHP compared to other object-oriented languages? PHP's data is weakly typed, which means we don't give a specific type when we declare a variable. We don't say this has to be an integer or this has to be a string or a date. PHP does its best to figure these things out from the data that's contained in the variable. PHP's objects are not explicitly type. Like in Java, you might say, oh, my payroll is of type payroll. And you can't do that in PHP because we don't type our data, and the object essentially becomes a kind of data. There's no automatic object detection. That can be very useful to have with polymorphism. It causes a polymorphism problem, if you will. There is no way to instantiate an object of one type into an object of a supertype. A supertype is a class that we inherit from. In Java and these sorts of object-oriented languages, we can stuff a lower-end object, lower on the inheritance chain, into something that's higher on the inheritance chain, and then deal with it through object detection. You can't do that in object-oriented PHP. Functions do not enforce a particular data type that must be returned. When we define a function in our object, we won't be saying this definitely returns a string or this definitely returns a double or an integer, as you might do in something like Java. So those of you coming from C++ or Java to PHP in an object-oriented way are going to have to get used to certain things not being there. If PHP is your first object-capable language, then you won't have to unlearn anything to use it. This lesson is on using the basic constructs of object-oriented PHP. Now I'm running on a Windows 7 PC, so I've already started WAMP, and I'm going to click on that, and I'm going to open up the localhost area. Now this is equivalent to the WAMP/www directory on a PC, and I have a working files folder set up here, and we're in Chapter 1. I'm going to demonstrate a few different files. One that's going to show PHP the normal procedural way, and then I'm going to show how we can make that object-oriented. Here's the file, hello world noop. So that's not object-oriented. Let me click on it to run it. And there it is. Just a simple hello world nope. Let's go look at the code. Now, I'm using a program here called TextPad, and I've already pre-opened the 3 files that I'm going to demonstrate. These are your working files that are found in Chapter 1. Here we are in hello world noop. Just a simple HTML page, body, heading tag, and the PHP involved is very simple. We assign the string to a variable name, and we pretty much just print the variable name. So let's see how we're going to make that object-oriented. I'll go over to the other file here, which is hello world OOP for object-oriented programming. It starts off the same way with just some HTML, but let's come down to the PHP code. The very first thing we see is something called a class. Class is a very key thing in object-oriented programming, and most of what we build will be put in classes. So you just type in the word class and then give it a name. In this case, hello world OOP. A class has a beginning curly brace and an ending curly brace. Now within that, we can put various variables and functions. These functions are often called methods in object-oriented programming speak, and for all practical purposes, they are the same thing. So this function is called display value, and you notice to the left of the word function, I have something else that you didn't have to do before. I put the word public. We could have gotten away with leaving it off at this time, but I want you to get used to putting it there. There are other options that'll be covered later. For now, make everything public. It's a function, so an opening and closing curly brace, and then the code in the middle pretty much looks like what we had before. Setting a string to a variable, printing the variable. Just like with a function, just because we defined a class doesn't mean that anything at all is going to happen yet. We have to write the code that will call the function on the class to get things to work. Now, on object-oriented programming, we generally don't run things directly off the class. Instead, we make an instantiation of that class and put it into an object. That's essentially what an object is in most cases. It's an instantiation or a copy of the class definition instantiated into a variable reference. Let's take a look at the next line and we'll see how that works. The first line that gets the ball rolling here is down here, and it comes after the class. It's not defined within a class. It's just standalone PHP. Now, as I'm fond of saying, anytime you see an equal sign, look to the right of the equal sign first, because that's what's going to be processed first. So here's a key word that we didn't use in normal procedural PHP. It's new. New is similar to create in some other languages. We're going to use new to make a new one of these. Hello World OOP class defined up here. We're going to make a new one of those. We're going to make a copy of it, and we're going to store that reference in $myHelloWorldOOP. Notice that this is a variable, and variable names start with a lowercase letter. Notice that the class, however, starts with an uppercase letter. This is a naming standard in object-oriented programming, followed by languages like Java and C++. You make your class names begin with a capital letter, and all function names and variable names begin with a lowercase letter. If you have another word within your variable, as I have here with display value, the second word can be capitalized, but the first character itself is lowercase. So this makes a new object. Well, just making a new object, again, doesn't really do anything that we can see. We have to use this object that we created over here and get it to run the display value function. The way it's done in PHP is we use something called a little arrow, and that's a hyphen and a greater than sign right next to each other. And it points to the function that we want to run on this object, which was a copy of what was defined in this class. That's how it works. We run display value, and the code will pretty much print as we had before. Let's go ahead and run it. Come back to the browser. I've actually stored in my home page the working files. So I'm going to go there to Chapter 1 and run this file here, Hello World OOP. And there it is. Runs pretty much just like the other one did. That's not the only way we could do it. That's the most common way. Let's look at another way. I'm going to come here with the third file, and this is called Hello World OOP Static. Now, static is a very key word in object-oriented PHP and in object-oriented programming in general. What it means is if something is static, I can use it directly off the class. I don't have to instantiate that class by making a new object. I can just use it as is. Here's the class, Hello World OOP Static. Here's the function. Function display value, just like before. But in front of the word function, I have the word static. It's a key word. When I put that there, that says this function display value can be called directly off of the class name. We don't have to make a new object. So let's come down here, and you see after the class, we only need one line to get this to run. But the syntax is a bit different. The function name is the same as before, and over here is the class name, not an object name that I created with the new command. In between these two is a : operator. Now that is used instead of the little arrow, the hyphen and greater than sign. We use this whenever we are using something in a static context, which we are now. We're calling the function directly off the class. This presentation is on setting up your computer to use PHP and MySQL. There's not all that much to know. Just about any reasonably new computer is going to work. You're going to need about 500 megabytes of hard drive space to install one of these three packages: WAMP for Windows, MAMP for Macintosh, and LAMP for Linux. Now we're going to show you how to do WAMP and MAMP. If you're on Linux, you're going to need to do that yourself. WAMP stands for Windows, Apache, MySQL, and PHP. MAMP, of course, Macintosh, Apache, MySQL, and PHP. And these special software packages that we're going to learn how to download will allow you to run PHP locally and MySQL locally and test out a great deal of your work before deploying it on an actual website. Now, the next thing you're going to need is a plain text editor, not a word processor. Do not use Microsoft Word or an RTF program, nothing like that. Here's a clue. If you don't know that you have a word processor or a plain text editor, if you can make a word bolded or italicized, you have a word processor. Don't use that. Those word processors have funny little codes built into the back of their file formatting, and sometimes those funny little codes can cause very unfunny things to happen on your web pages that you can't see because it's white space to you. So use a plain text editor. For this class, I'm going to use TextPad for PC. It's at textpad.com. A free editor for the Macintosh is TextWrangler. A lot of people like BBEdit. Also for the PC, just Notepad can work, or Notepad++. Any of these tools are fine. Just make sure it's a plain text editor. These editors that you'll see, that you can download for free, most of them, will have color coding on the windows as you're looking at them, as you're doing coding, but that color is not really part of the text. It's just a visual cue to help you see things like brackets and keywords in the programming language like PHP. They're just an aid. Now the third thing you need is an internet connection. You don't really need the internet connection to develop PHP and MySQL here using WAMP or MAMP, because we're going to run that locally. But you're going to need to do research sometimes on php.net is the main site for PHP. You're going to want to look some things up, maybe go beyond what I explain in my presentations. Likewise for mysql.com. And I have a note there that it's really Oracle. Oracle now owns MySQL, and so they're the ones supporting it. I'm going to go over to these websites briefly. This is php.net. It's the main site for PHP. One really nice tool here is there's a search for box, and it looks in the function list by default. If you don't want to just look for a function, you can look at all of the online documentation by selecting that as well. So if I'm looking for a particular function, such as print, I click the little arrow there, and I get some information about the print function. This can be handy. Not only does it have the basic syntax of what the statement does, often people have made contributions of how you might use the print statement, and then there's some information about other things that may be of interest to you that relate to that function. If we look at the MySQL site, mysql.com, you can see we have product services and etc. And there's information about the various editions and documentation. So keep this site in mind as well as a resource as we proceed through the class. So that ends the presentation on what you need to do to set up your computer to get started. This lesson is on installing a WAMP server on a Windows-based PC. So here we begin with a very blank slate. Let's start with a browser. I bring that up, Google, and I'm going to look for WAMP server. Brings me up to the first hit here is exactly what I need. So we'll give you some information about it, but right now I just want to download it. Now you have to know whether you're a 64-bit PC or a 32-bit. I can't help you with that. You've got to download the correct one for your operating system. So 64 bits is what I'm on, so I'm going to click that. You'll get this form. You can ignore it and you can go right to this link that says download it directly. So you get a little advertisement here. Can't be helped. Download will start in 0 seconds. Now, you're going to be given a chance to save this file. So you need to do that. I'm going to skip it here. I've already pre-saved it because it takes about 5 minutes to download. And that's not all that exciting to watch on a video. So I'm going to cancel this instead of saving it. You save it. And I'm going to go to where I did save it. I have it here. Went to my downloads directory by default. And here's a nice big icon for the WAMP server. I'm going to double click on this. Are you sure you want to run this software? Yes, you are. Click Run. And then yes, we want to allow it. It gives us WAMP Server 2 Setup Wizard. And this shows the various versions of Apache and MySQL. So let's click Next button. You'd better accept the agreement or you're not going to get the software. It's defaulting to go to the C WAMP directory. I highly recommend that you accept their suggestion. Next. I'm going to go ahead and check these two boxes and get the icons. Next, it says Install. Install. Click on it. Doesn't take very long. You can see up there that it's installing the various pieces of software that we're going to need. That's very nice, free. It's very easy to download and use. So we're getting near the end here. And voila. Now, one thing it does is it says, please choose your default browser. If you are not sure, just click Open. I'm sure I don't want Windows Explorer. So I'm going to go navigate to the browser I like. I prefer Firefox. So I'm going to go to the directory. Let me go down to Program Files, x86, because it is a 32-bit program, even though I'm running on a 64-bit system. There it is. There's the directory. Open that. Click Firefox and say Open. So it's finishing the installation. Should be done in just a second. And now I can put localhost in here. You can put your email in there if you choose. That's not something I'm going to worry about, so I'm just going to leave it there as localhost. And it says launch WAMP Server 2 now. So we'll say, okay, let me finish that. Let's look down here. See how it's red? And then it turns orange. And then it turns green. That means success. We're running. Let's left click on this. We can see all the things that came with the localhost, PHP MyAdmin, which is a tool we are going to use here. Apache, PHP, MySQL. All these different individual software packages were installed and configured pretty much properly the way you need them. Pretty much the only thing that you're going to use here is the PHP MyAdmin. It's possible you might sometime restart all services if the server goes down for some reason locally, but that's about the only two things that I ever really have to deal with on a regular basis. So, we're running. This is good. Let's go ahead and look at what it did for us directory-wise. So it created the WAMP, and this www area is called our root directory. Here's the index PHP. This is going to let us run a program. We're going to test it. So I'm going to say Firefox. And you look at that and you go, oh my, that can't be right. And it's not right because it opens it up in the file system we have to replace all of that, including the www, with the word localhost. And now I'll put the cursor over there and I'll hit the Enter key to run it. And there we are. We see some information about the configuration, some links to get more information about these tools. So this is good. This means that we ran this PHP program on our installed server. There's another file there I want to point out that helps us test our connection in PHP and MySQL called test MySQL PHP. It won't work right away. I'm going to show you it failing just so you can see that. Now we open it up in the file system. Let's replace this with localhost, Enter key, and we get a bunch of these errors. There's a reason for that, and I'll show you what you have to change to get this to run. So go back to the directory. I'm going to open this up in TextPad, a plain text editor that I'm using. This is a very simple program that issues a PHP function called MySQL_connect to connect to the database, and it's going to tell us whether we succeed or not. Well, we didn't succeed. You have to give it the host name. Well, the host name that we're running with locally is localhost. The user that we are when we're running WAMP server is just called root. And our password, now this is going to be tough to remember, it's blank. Nothing. It's an empty string. There's nothing between the two single quotes. Tick, tick. I'm going to save this, and I'm going to go back to this one where we got the errors. I'm going to just try to run this by refreshing the page. And this time, connection okay. Life is good. We're all hooked up. I'll show you one more thing. I'm going to take this, and I'm going to exit from the WAMP server. Because when you first log on to an account, it won't be running necessarily. So what you do to get it running again is you go to perhaps your start bar. If you have it there, you may have to navigate for where it is. So I go through Programs, and it'll be down near the bottom under WAMP server directory. There's what you're looking for. Start WAMP server. Click it, and you see it's red, orange, and then green. Once it's green, we're ready to go. We're up and running. Congratulations. You now have the software you need to run the PHP programs and MySQL statements that you're going to use for the rest of the class. The MAMP software bundle represents one of the easiest ways to get started with Apache, MySQL, and PHP on a Mac OS X. You can download the MAMP software from this website at www.mamp.info. Make sure you're looking at the English version of the page. You see, there are two versions of MAMP, one simply called MAMP and the other called MAMP Pro. When you download the software, you'll actually be downloading both at the same time. Go to the Downloads link, then click on the Download link here, and follow the rest of the prompts to download the software to your hard disk. You'll see that the software is downloaded to a zip archive file. When you extract the archive file, you end up with this installer package, mamp.pkg. To run the installer, double-click, follow through the prompts, including reading and agreeing to the license agreement. Finally, click Install. There are no other options for the MAMP installation. However, you will be prompted to type your administrative password. Installation should take just a few minutes, as the files are written to your hard drive and placed in your Applications folder. Once the installation is complete, click Close. Then, in Finder, go to your Applications folder. You'll see in your Applications folder that there are two folders named MAMP and MAMP Pro. We'll be using the free edition of MAMP, and we won't need MAMP Pro. You can choose to keep the folder if you want, or if you prefer, you can move it to the trash. It's up to you. Before starting, we need to make sure that any copies of Apache or MySQL that are already on my Mac are turned off. Go to the System Preferences. From there, go to Sharing. Make sure that web sharing is unchecked. That will make sure that the version of Apache that's included with the Mac OS X is off and won't conflict with the version that's included with MAMP. If you installed a native version of MySQL, check that as well and make sure that it is stopped. I currently do not have it installed on this machine. However, if it was, it would be located down in the bottom of the System Preferences. Now we're ready to fire up MAMP. In the MAMP folder, there's a MAMP application and a critical folder named htdocs. The MAMP htdocs folder is in your web document root, where you place your HTML graphics, PHP, and other files that you want to call from the web browser. Let's go back to the MAMP folder and double-click MAMP to start it up. When you first start up MAMP, the server should fire up automatically, and once they start, this home page should appear. Notice that this home screen, it tells you that you're running MySQL on port 8889. That's a non-standard port. We'll change that in the next lesson. In addition, you see up here in the URL bar that you are running Apache on port 8888. Again, a non-standard port. MAMP comes out of the box this way to allow you to run these copies of Apache and MySQL at the same time as the version that are included with a Mac OS X. However, if you prefer, you can use the standard settings as well. Let's verify that our database is working. This is the fun part. Click up here on PHP MyAdmin, and you should see this listing showing you that PHP MyAdmin is working and connecting to your MySQL database. So that's all there is to it. MAMP is incredibly simple to install. There are other options that you can use, and we'll look at those options in other videos. When you install MAMP, Apache and MySQL are installed with custom ports. You can find out what the current ports are by going to the Start page. If you look at the web address that's used to open the Start page, you'll read the port number 8888. That's what Apache is listening on. Down below in the MySQL section of the home page, you'll see the port being used by MySQL defaults to 8889. These are non-standard, and in fact, if you're going to try working with certain products, such as Dreamweaver, they're not going to work. So before you continue with your development work, you should change the ports back to the standards of port 80 for Apache and port 3306 for MySQL. Here's how you do it. Go to the MAMP application and click Preferences. In the Preferences dialog, click Ports. Click the button labeled Set the Default Apache and MySQL Ports. You'll see Apache changes to 80 and MySQL to 3306. Click OK. Both Apache and MySQL will restart, and you might be prompted for your administrator password. Go ahead and type that in. Then watch the indicators to see whether the servers are starting up correctly. They should be set to green, just like these are. Once the servers have started, open the Start page again. This time, you should see that the Apache server is listening on the standard port 80, indicated by localhost, without a port number, and MySQL should be listening on port 3306. Once you change to the standard port for Apache and MySQL, you'll be able to work with your MAMP installation. If you have any troubles changing ports, try this. Go to the Preferences and click Reset MAMP Ports, and click OK. That will cause the servers to restart using the custom ports that MAMP set up. Then go back to the Preferences again, and once again set the default Apache and MySQL ports, just like we started. You sometimes have to help MAMP a little bit just to get it to keep the proper settings. Once again, you can always confirm that the servers are using the correct settings by going to the Start page and looking at the web address and the MySQL configuration. This lesson is on defining classes in Object-Oriented PHP. Let's go back to the home page that I've set up, which brings us to the working files. And I'm going to open up a file called simpleclass.php that you can find in your working files. So I click on it, and it just simply puts up these headings, My Simple Class. Let's go ahead now and look at the code. We have the top of the web page as always. Come down here and let's look at the PHP code. So we have the word class and then the name simple class. I'll point out again that it's good to start your class names with a capital letter. That is the naming standard for object-oriented programming. Now here I have something a little different than I've shown you before, as I defined a variable, $myMessage, as public, and gave it a string. I'm not doing this as part of a function. I'm doing it as part of the class. So this is called an instance variable when it's part of a class. You'll learn more about the types of variables that can be defined. A synonym for variables in a class are properties of the class, and when it becomes instantiated, it's a property of the object. Remember that a class is a definition of how an object will be built, or instantiated, as we say in object-oriented programming speak. Now let's go down here. We have the word function and display message. If we look down here, this is a little bit different than you've seen before. I have a print, but look at the way I've specified that I'm going to print this message. I have $this. This is a keyword in Object-Oriented PHP. What it means is the class that we're working with. That means it's found as a variable defined within the class, not within the function, but within the class. My message is that variable. But wait a minute. If you look over here, it's got a $sign in front of it, and that's what we're used to seeing, right? With PHP variables, there's always a $sign in front of it. Well, the proper syntax is to put the $sign in front of this. And then we use the little arrow, the hyphen and greater than sign, and then the variable name without the $sign. This takes some getting used to. When you're used to working in procedural PHP and you come to this kind of syntax, it feels a little odd to stick the $sign all the way out here, but that's the only way it's going to work. When you get an error, and you will, just look for that. Now let's go down to the part of the program here, the simple class PHP program, where we're going to execute code that's associated with the class. Here's my equal sign, so I immediately look to the right and I see the word new. So I'm going to instantiate an object from the definition defined in simple class. So I'm going to store that in my simple class as a variable. Notice that the m is lowercase, indicating that it's an object variable, not a class. And then we use the little arrow off of this object to call display message. And you saw this run already. We went ahead and ran that. It just doesn't do that much, but at this point we're trying to learn the mechanics of object-oriented programming as it's implemented in PHP. I like to point out from time to time the differences between PHP and truly object-oriented languages like Java. Many people are used to those, and when they make the transition to PHP, it's a little bit different. In Java, for example, instead of this little arrow, we use a period, and that's the dot notation that you may be familiar in Java and JavaScript. They don't use that in PHP. They use the hyphen and greater than sign instead to get at a method or function that lives on this object. Let's look at an example that's just slightly more complicated. This is a simple class. This is also in your working file, simple class with return.php. And I'm going to go up here, see the code. This one's going to return a value from the function and do this a little bit differently. Same as before, I just called it simple class. My message, my simple class with return. Display message. It's doing the same thing before, but instead of printing, it is returning the value. And it's not going to issue the print statement, it's going to do the return statement. We'll handle this down in the executable area of the code. Let's go down a bit. Here's the new simple class, my simple class. We call the display message just as before with the little arrow, but this time we receive the information that it returns into a variable over here. $return value abbreviated, and then I print it there. So let's go back and actually run that. And here are the files that I'm illustrating. This one's simple class with return, found in your working files. Click on that, and there it is. My simple class with return. This lesson is on defining class properties using object-oriented PHP. Let's go first to some code. I have pre-opened the class properties PHP file that you can find in your working files area. Go down here and we see the class definition, and the name of it is just called class properties. Capital letter as the first letter of the first word, and then I've capitalized the second word, properties, as well. I have two properties defined as part of this class. I tend to think of them as variable names, but as you'll see, this is a variable and this is a constant. Let's talk about that for a second. Here we have $myradius, lowercase m, because it's a variable, equals 5.5. Here we have the word const, short for constant. If you're familiar with other object-oriented languages like Java, instead of the word constant or const, it would say final space static. And we'll get into what that means a little more as we go on. Suffice it to say that a constant is capitalized by naming standards. The PHP doesn't care whether you capitalize it or not, but it's considered a naming standard to take a constant and make that obvious by having every letter in the name of the property capitalized. So MyPy, I've defined a version of pi that just goes to this precision. Let's go on to the function defined. Functions are often known as methods when they're part of a class. For all practical purposes, a function and a method are the same thing. And so here I call this one calc_circum, short for calculate the circumference. Remember, I'm making everything public here. I don't have to do that on the const. There's a little formula. I always look at the equal sign and look to the right. 2 times. And look at that. That's a little different. We have the word self. Over here we use the word this and a little arrow. But here I use the word self and 2 colons to get to MyPy. It would be a little more obvious why we use the 2 colons if instead of const it said final static, because the 2 colons are used to indicate anything that we're going to access in a static context. Since that's what a constant really is in PHP, object-oriented programming, you're going to have to remember if you use a constant that's defined this way, to use the double colon and self to be part of the self class. Now, as a reminder, when something's static on a class, it's accessible without having to instantiate the class. Now, in this case, it wouldn't make much difference, but this is the right syntax to get at this for a constant or anything that's static. Times, we put the $this. Remember, we put the $sign in front of the this, not in front of the m, as is done up here when we define the variable. $this, little arrow, hyphen and greater than sign, MyRadius. So we figure out the circumference in here and then we return the circumference. Let's go down, just take a look at the code again that executes all this. New class property. So we are going to make an instance of this class, and I put it into an object called myClassProperties. I'm going to run the function that is part of this object and receive the return value into here. I broke the print statement over 2 lines just so we could read it. The circumference of a circle with a radius, space, of myClassProperties, little arrow, myRadius. Because I'm accessing myRadius as a property, that's up here, a property of this class, I have to use the little arrow. It's an instance of this class. It's been created as an object over here, is why I need to use the little arrow. If I had defined a public static, if I had put that there, then I could get at this with the double colon methodology in myRadius instead. But I didn't define it that way, so I'll take that away and we'll leave it like so. So we have to spell this all out like this, because the thing about object-oriented programming is properties, like variables that are on a class, and functions or methods on a class, they don't live out in space on their own the way they do in procedural PHP. They are always part of an object. Sometimes object-oriented programming can feel a little overwhelming, a little strange. But if you just think of an object or a class as an organizing name, we're going to put all the payroll stuff on the payroll class, all the functions that would do payroll kind of things, and all the properties that would mean something about a payroll or a paycheck. It's just a way to keep things together that belong together. A class is really an organizing principle where we keep functions and variables, or properties if you will, all together that seem to go together logically. So that's the idea behind this object-oriented programming. This lesson is on defining methods using object-oriented PHP. I'm going to start with some code here. I'm going to go to TextPad and open up the sleptyears.php program that's in your working files area of Chapter 2. And let's take a look at the class here. I have a class, SleptYears. and I've defined two variables, two instance variables, one for the hours that's slept per night by the user, 8, and the age of 54. And now I have a function here, make everything public, and within there I get a handle on these variables, this my age times this hours slept per night divided by 24. And this is going to calculate how many years of my life that I've actually slept. I'm going to return the slept years, and I'll receive that when we run the code down below. We create a new slept years into here, and now that contains the slept years object called MySleptYears. And here I run the calculate slept years function. On the object, it returns the value, which is the number of years that I've slept. So you have slept so many years of your life away. Let's make that say years of your life away. So I'll save that and I'll run it. I can click on the little world icon here and cancel this. And what it does is look at the file system, but I want to look at localhost. So I'm going to type in the word localhost there in front of it, hit the enter key, and there it is. You have slept 18 years of your life away. Let's go back and look at some other code where I do this in a little bit different way, because this is about defining methods and using them. Here, I'm going to change this around where I pass data to this function. So I'm going to the slept years past data.php, also found in chapter 2 of your working files. Let's look at the difference. I've got the class, slept years past data. I've got these variables still defined with the same values, but now the function is accepting arguments for hours slept per night and the age. And then in the calculation, it's using what was passed to the function. Instead of coming out here and getting this, my age, it just uses what was passed in to do the calculation and then returns it. That works fine, but down below our code needs to be a little different to get this to work. I have new slept years past data. There's the object. This is a long statement now because I have to write somewhat more verbosely, if you will, to get this data to be passed. I'm going to call the calc slept years function on the object. Now the data that I'm going to pass to it also has to use this longer approach. My slept years past data, my age. There's the little arrow pointing to the variable my age. Remember again that you don't put the $sign here in front of my age. You put it just at the very beginning in front of the object name. I have to do the same thing over here for hours slept per night. You have slept blank years of your life away. So let's go ahead and run this. I'll use the world icon again, cancel that, and I'll change www to localhost and hit the enter key, and there it is, still 18 years of my life away. This lesson is on creating and using objects. I'm going to go over to the chapter 2 working files area and I'm going to come up and run a program. This is called fruit1file.php. So I click on it. It says I have 9 pieces of fruit. Let's take a look and see what's going on here. And here I have fruit1file. So I'm defining the class, fruit1file, a method or function in here called addFruit. I'm passing some data in here, apples, oranges, and bananas, adding them up and returning the total fruit. So this data is just coming from 3 variables that I've hardwired, and this is just the procedural part of PHP here. I create a new fruit1 file, new, and object into myFruit. MyFruit calls the addFruit function, and it passes in all 3 of those variables I defined right above. There we go. The return value contains the total. You have, in this case, 9 pieces of fruit. What I really want to illustrate here is up to this point, we've included the class file definitions in the same program, same PHP file. We've included the code for the class file as well. I want to break this up. I want to go and put the class file in a separate program. Got a PHP file here. You got to have a beginning and ending PHP tag. And then I've just got class, the function, the same thing I had before, add fruit, total it up, return the total. So the class is there, but I now want to run the code from the class in a separate program. To be able to get at the class, I have to include it in the program. Unlike languages like Java, where you can import a whole series of classes at once, here you'll either have to put all those classes in one PHP file that you include, or include all of the files separately if you have one per class. It's a judgment call on how you want to go on that. But in this case, we've sort of cleaned this up. We just have the include, which brings in the class code. This is the same as we've seen before. 3 variables with values, the new fruit into that object, call the function on the object, passing the data, and we get you have 9 pieces of fruit. Let's go ahead and run this just to prove that this works the same way. I'm going to go ahead and take out the WAMP www and put in localhost and hit enter, and there's my 9 pieces of fruit. Okay, let's try something else. I'm going to introduce another construct called the constructor. Let's go to another file here. This is called fruitconstructor.php and is in your working files area. So here's the class, fruit constructor. Got some instance variables, public apples, oranges, and bananas. Now, here's the key word. This is a function. It's a special function known as a constructor. We have them in Java too. In Java, you would name a constructor the same as the class name, but you can't do that in PHP. And in Java and C++, you can have multiple constructors, but in PHP, you can have only one, and it must have this exact name. 2 underscores right next to each other, and the word construct. I'm passing data to this method, this function. I've got C apples, C oranges, C bananas. Now, all this constructor is doing is it's taking what's passed in and assigning it to the value of these variables that I've defined up here. These are instances of the object. A constructor, as you may have already figured out, is what runs when you first construct the object. Now, we construct an object with the keyword new. You've seen it before. I'm going to take you over there in just a second. The idea of object-oriented programming is that with each object, the data can change as long as it's particular to the object that you're using. So I don't have to have just one fruit constructor object instantiated. I can have more than one. And I'm going to illustrate that in a second. Before I go through the rest of this, I want to go over to the fruit program constructor program. Fruit call constructor. Fruit call constructor. Just wanted to let you know that we're going to call the constructor when we build it. Here's the data, same data we had before. Or this is actually 543, so it should be 12 in this case. The keyword new. We've had this before. We've run the new class name, but in every other case up until this point, let me take this out temporarily, we just had parentheses. So what we've really been doing behind the scenes is we've been always running the constructor of the class, and that's what creates a new object. Now, we hadn't specified a constructor before, so by default, there is a hidden or default empty one. Doesn't do anything, but you still have to put these parentheses there syntactically or it will not work. Now, in this case, we've developed something that we can pass data as we create or instantiate an object from the class. So we create one with this data, 3, 4, 5, and I get a $myFruit here that has that kind of data attached to it. I run the addFruit function, and I don't pass any data, because if we go back here, you'll see the addFruit method or function is using this apples, that's up here, and this oranges, and this bananas. It's using whatever it's been set to, and then returns the total fruit. I got that data instantiating an object from the class. I'm not restricted to having one of these. I've got a new fruit constructor here, return it, and I see I have however many pieces of fruit. But I could do this here. I have new fruit constructor, and I pass in 8, 3, and 4. That ought to be equal to 15, not 12. I clobbered what was there before. I don't need to keep it. I run again the addFruit, get the return value, and it says you now have however many pieces of fruit were totaled up. Let's go ahead and run this and see this happen. Cancel here. We'll go ahead and replace that with localhost and then run it. And there we are. You have 12 pieces of fruit. You now have 15 pieces of fruit. It's important to know how to use a constructor. This lesson is on using static properties and methods with Object-Oriented PHP. Let's go over to my localhost working files chapter 2 area, and I'm going to run this program called fruitprogramstatic.php. And there it is. I have 6 pieces of fruit. So let's go ahead and look at the code itself. I have this broken into 2 parts. First, the class called fruitStatic, and I have a static function called addFruit, which receives 3 arguments, apples, oranges, and bananas, and then it just adds them together and returns total fruit. But this being static, it means that I'm going to use different syntax in the program that I use to run it than I do when I instantiate the class. Here's the program I ran. We include the fruitStatic PHP program, which basically is just the class that I'm using in this example. I've set up a couple of procedural variables here, my apples, my oranges, my bananas. I've just made a comment here that before we did a new fruit into an object, and then we called the addFruit as a part of the object right here, and using the little arrow. But with static, we use different syntax. We specified the class name itself, : and then the method or function name, passing the 3 variables to the function. It returns how many fruit I have, and then I print out the message with the fruit. So let's look at another example here. I'm going to look at fruitStatic2. In this case, I put variable names in there that are also static. Now, a static variable is also accessible by going right off the class. I don't have to instantiate fruitStatic2 to get at this variable because it's declared as static. 7, 5, 6 are the numbers that I have for the fruit, and I have the same thing as I had before. addFruit is a static function. It's exactly the same. So let's go over and run the program fruitStatic2. So here it is. It's being included. Now look what I've got to do here to set the values of these variables that I used. Last time I think I just put the numbers in here, but here I say fruitStatic2, that's the class name. Notice the big hint there is that it's a capital letter at the beginning, not a lowercase letter, which we use for variables and for function names. : and then apples. So it's going to get the value of the $apples that's on the class because $apples is static. Same thing with oranges and bananas. Once I have it over there, of course, I can use those to pass to the function, but the function is called in a similar way we did in the last example, : addFruit. Return value, and you have the number of fruit. That's how you use static properties and methods with Object-Oriented PHP. This lesson is on the Assignment 1 requirements. Let's go take a look at the steps you need to follow. First, I want you to create a web form that allows the user to enter their first name, their age, and how many hours they sleep at night. Now, in the class that you create to hold all the functions and variables, make sure that it uses a constructor to receive the information that was entered on the web form. Specify the number of hours that are found in a day in a constant variable. Then, when they click the Calculate button, use an Object-Oriented PHP function to calculate how many years of their life that they have slept, and then display a message in the following format. Hey Steve, you've slept 19 years of your life away. Let's take a quick look at what this looks like. My unconscious life, enter your first name, age, number of hours you sleep at night, and calculate. So I'll put in my name, age I'll enter as 57, and I'll say that I sleep 8 hours. I click the Calculate button. Hey Steve, you have slept 19 years of your life away. This lesson is on the solution to Assignment 1. Let's go over to the web page that shows Assignment 1 running. The goal here was to figure out how many years of your life you've spent sleeping, and it's called My Unconscious Life. We enter our first name, my age, I'll put in 58. The number of hours I sleep at night we'll say is 8. And I'll hit Calculate. And it comes back and it says, hey, Steve, you slept 19.3 years of your life away. I didn't round it off. I just let everything come out as is. So that's a fair amount of time to sleep away. Let's take a look at the code and see how this is calculated. We're obviously employing object-oriented concepts here. You've got some standard heading area. I even put a little styling in on the body to make it look a little better. Gave it a background color of silver and an Arial Helvetica font. Here's the heading. One thing we need to do here is we're getting our data from a form instead of just setting variables with values. I've got form, the name form1. The method is post, which we generally want to use on forms. And on the action, I did a little trick here to make this recursive, which means it's going to call itself each time we click the button and start again from the top. So I've got a beginning PHP tag and ending tag, and then I'm just echoing or printing the server variable with the PHP self, and it goes ahead and will call itself. Truth is, you could leave action off completely and it would do the same thing, but this is considered more correct. I've got the fields. I'm entering my first name. I've got an input type equals text. User first name is what I called it. My age is called user age, and I've only made that 2 places. No 100-year-olds can use this program. And how many hours you sleep at night, user hours, and 2. Again, that should hold as many as we need. So here we now have the button that you see is a type equals submit button, and the value, which is what you saw printed on the button, if you will, as just the word calculate. Here's our class. I call this class just assignment 1. Now we have a constant defined at the top, hours per day. 24. We're going to need that in our calculation, so I made a constant out of it just to practice that. And remember, with constants, you capitalize every letter in the variable name. Hours per day, all caps. 3 instance variables here, the first name, user age, and the hours slept per night, so user hours slept. Now we have a constructor. I'm going to build this object, and I'm going to pass data in when we build it with the new keyword. So here it is, the constructor. I'm going to send in a first name, an age, and hours slept. And of course, it's going to do the standard thing that we've seen so far. It's going to take the first name and set it to the instance variable first name up here. Same with age, user age, slept. Here's some functions. I have calculate slept years, and I also have display message. That's going to put out the final message. The method that does calculation, it's going to say, take the instance variable, the value of the user hours slept, and it's going to divide that by self, hours per day. Remember, constants are inherently static, so we have to use the static syntax. Instead of using this, we say the word self. So we're going to divide how many hours I sleep per day. I said I slept 8, right? And I'm going to divide it by 24, which is what is hours per day. So if I divide 8 by 24, I essentially get 1/3. Now I can take 1/3 and multiply it by however old I am. I put 58. So 1/3 of 58 is how many years I've slept. And I've just put this over here and called it $slept years and returned it from the function. Now the display message is actually going to call that function. Calc slept years, and it's this calc slept years because it's part of this class up here, the assignment 1 class. And it returns it. And I get the slept years again. I use the same name here. I didn't have to because I'm really passing data, not the name, but it was convenient just to call it the same thing. And then I print out the message. Hey, whoever you are, Steve, you have slept this many years of your life away. So let's go down here and look at the code that executes it. Especially when running locally, I need to use the isSet to make sure that one of the fields is really there. This is a little trick to detect whether this is the first time you're running this program before the form has had a chance to fully render. You obviously don't want to start calculating things while the form gets displayed for the very first time. The user needs the time to enter the information and click the button. So this allows us to call this program, this assignment1.php program, and display the form without trying to do the calculations. From then on out, I want to assume that I've put the information in. So I use the $_post to get the information on the form. The user first name, that's the name in the HTML field, user hours, user age, and I put it in these various variables I've set up here. And now when I create a new assignment 1, and that's a class in this case, I just pass those variable names in to it, and it builds it and puts it in the My Assignment 1 object. Now, all I have to do there is run the display message function as a part of that object, because the display message function does the work of calling the other function that does the calculation, the calc slept years. So this works pretty good. This lesson is on extending a class in PHP. Here's where we begin to use the concept of inheritance. One class will inherit information from another class, essentially its properties and methods. Let me go over here to the working files area for chapter 3, and I'm going to run something here called animal program. Click on that, and it says Lassie is a collie, my animal is a collie. So let's find out what that's about. I'm going to go ahead and look at the code. Here's the animal PHP program where I specify the classes that we're going to use. So we have a class animal, and the animal is a type. It's a type of animal. It's a dog, it's a giraffe, it's something like that. Now we have a constructor here. Remember, underscore, underscore, construct. And I'm passing the type in. So when I build this object, the animal, I think I'd want to put in what kind of animal it is. And it just takes what's passed in and then makes the variable that's defined up here, public type, be whatever was passed in. Now I have one function here, and it's called show type. And it's in a paragraph. It says my animal is a, and we use the instance variable that was defined up here. Whatever value is in there is what would show. So remember that name, show type. Let's go down a bit. Now it says class dog extends animal. Might have been easier if they used the word inherits, because that's what it's doing. It's inheriting from that class, but extends is the key word we have to use. When you extend something, it's almost as if you took all this code and just copied it in the dog class and didn't extend anything. Almost like that. One thing that doesn't come down is the constructor of animal in this case. That's considered the parent of dog in this relationship. There are other restrictions of things that won't come down where we make this private instead of public, but we'll save that for a later lesson. So for right now, pay attention to the constructor that pulls in type. Here's the class dog extending animal. So the animal has a name. And we have a constructor here too. And this says parent, : construct collie. This says call the constructor that was defined in the parent of this class. Its parent is animal because that's what it's extending. So this constructor is going to get called when I make a new object based on dog. I don't really want to instantiate an animal because an animal is not enough information. I want a dog that's extended from animal, and we'll see how that's done in a moment. The : because it's considered to be static context in this regard, so you have to do it this way. Here's a function, it says show dog. The other function we had said show type, but that lived with the animal class. And what I've said to you is this stuff gets pulled down, essentially. It's almost as if you typed it here. Same thing with this variable. It's almost as if you would put it down here after public name. Behaves the same kind of way. What are we doing here? We have a function. It gets the name that's passed in, sets this variable up here, this instance variable name. Then we print it out. This name, whatever name it is a, and this type. Okay, type is the type that was defined in the animal class up above. Let's look at the program that runs all this. I include animal PHP. In this case, animal PHP, of course, holds the two classes, the animal class and the dog class that extends animal. So I'm going to make a new dog. I'm not going to make a new animal. New dog. And I'm going to put it in $mydog. I'm going to run the showDog method that was on the dog class. Let's go back, take a look. Here it is, showDog. I'm going to run that method. And I'm giving the dog a name of Lassie. But here I'm going to run showType on the MyDog object. Show type isn't on the dog class, but it is in the MyDog object because that object was built on dog extending the information that was in animal class, and that has a show type function. So that's why we got both of those. Lassie is a collie. My animal is a collie. So this works really well. And this gives us a way to extend information that belongs in an upper class or a parent class and gets inherited down to the children. This kind of extension can go on for a while. You can extend one class and that class can be extended by another and so forth. And you'll see further examples as we go along. This begins part 2 of our lesson on how to control access to properties on objects in Object-Oriented PHP. We're going to pick up where we left off last lesson. Let's begin by looking at some more code. I've got a series of programs here that illustrate the different scoping. This is called generateAnimal.php. It's found in your chapter 3 of your working files. And we have the class animal. So I said species of animal. And I made that public. This is the way we had been doing it before. So I'm going to show you the different ways. We have a get species and a set species, very similar to what I did with the pets. I've got a class dog extending animal, and I've got a public breed. So again, a get breed and a set breed. I'm still controlling it through functions, or I can, but because I made this public, I didn't enforce in code that a programmer can't access this variable directly. So let's go down, and then I have my dog extends dog. So you can see we can continue this extending for a while. And I have the dog's name. I have a constructor here where I pass information, and then of course I use this constructor to set the variables. Now look, I'm trying to set this species. Well, that's all the way up here. But because it's public, I can see it all the way down here. Same thing with breed, that's in the dog class. It's like it was in my dog originally. It's almost as if I keyed it in there. And then show dog is going to put out this message. So what do we have here? I create a new dog with a new my dog, spaniel, and his name is Woof Woof. There's the object. I show the dog, and then I set the breed. I'm going to use the method. I'm not even accessing the variable directly. I could because it's public. But here I'm running the method, set breed to be collie on my dog, and then show dog again. So let's go ahead and run that just to see how that plays out. And I'll change the front here to localhost once again. Hit the enter key. My dog is a spaniel named Woof Woof. And then remember I changed the breed. So now it's my dog is a collie named Woof Woof. Let's look at some other code. I'm going to make some changes here. I have generateAnimalPrivate.php. Again, all of these are in chapter 3 of your working files. So here's the animal. Now this is called private species. Okay, that's the way we normally want to do it, or one of the ways we might normally do it. Everything else is the same, a get and set species. I have a private breed, same thing, get, set breed. And I have private dog name. Constructor, set species, a species. Now this is different than what I did before. Before, I tried to set that species variable directly. I'll go back to the generate animal. I took what was passed into the constructor and I set that variable directly. I can't do that when I make that private. If I were to try to do this line, I would get an error saying, I don't even know what you're talking about. But that function called set species, that is public, so that is usable. Here it is, set species, public. So I can use it anywhere. So we have to use the methods to set the values on those classes. So here we are, get dog name. This is pretty much the same. Here, I'm going to run the get species and get breed. I cannot get those variables directly. In the last program, I said this breed, even though that was on the dog class. Well, because it's private, can't get at it directly. I have to run the method or function get breed and pull it back into this. Everything else is the same except I made the breed a shepherd. I'll go ahead and run this and change to localhost. Hit the enter key. Dog is a spaniel named Woof Woof. Dog is a shepherd named Woof Woof. Okay, now one more file. Now here I'm going to show you the difference between protected. So instead of making these private, I made it protected. A private variable, of course, cannot be seen by any class that extends it. Private can only be seen by the class that's there. But protected says I can be seen by any class that extends me, but I can't be seen outside from any other class or from any other code, like down here. In fact, I have a fatal error where I try to access my dog breed again. And if we go up here, my dog breed is up here as part of the dog class. Because it's protected, I can see it in my dog, because that's part of the extension, but I can't see it outside of that class when I run code. Let me run this real quick just to show you what I'm talking about. Localhost. So I get the spaniel Woof Woof, the shepherd Woof Woof. Once again, undefined variable, fatal error, empty property. That's the same idea as we had last time with the private. Let's go ahead and go back to the code. I can access that variable within the showDog function. This breed is not in my dog, it's in dog. Let's go up to dog. See, it's up here. When it was private, I could not access it here, but because it's protected and it's part of the chain of extending, it's available to me. So it works out very well. So that's the difference between protected and private. I would say protected is probably a little better to use. Notice here I have private dog name, but this is the last class in my chain. So I really don't want any of these variables, any of these properties of the object to be accessible except within code within my classes and in the class chain of extension. But I don't want anything outside that class to be able to get at it directly. I want to run methods like showDog, setBreed, that sort of thing. This presentation is on using an abstract class in Object-Oriented PHP. Now, the idea behind an abstract class is to prevent you or any other programmer that might be working on your team from trying to instantiate a class that should only be used for inheritance, but not instantiated itself. For example, we have an animal class, and derived from that's a dog class, and then derived from that is a specific dog class. I'm going to show you this in the example, but you don't want to instantiate a generic animal. Doesn't make any sense. And yet, you may want to put things in an animal class that could be derived or extended by other classes from any other class of animal. That way you get the benefit of inheritance, but not the accidental instantiation of something that doesn't make sense to live on its own. So let's go ahead and look at some code here, see what I'm talking about. In this first file, I have abstract animal. So you see I have the keyword abstract in front of the class. A lot of what's done in object-oriented programming, you'll see this in other languages like Java as well, a lot of what's done is what I call traffic cop stuff. We're trying to prevent certain things from happening. Make a variable private because you don't want it inherited. You make something abstract because you don't want it directly instantiated. So in this case, we have an animal, and we're going to keep track of the species of the animal in this class. And we have the traditional get and set functions. So if we go down, we see that dog extends animal. But we also made dog an abstract class. We don't want a generic dog walking in through our door either. Let's go down a little bit more. We have my dog. This is going to be a specific dog, extending dog, which of course extended animal. Now this is not abstract. We intend on instantiating a dog. If we look down here, we have our constructor, and we're going to pass the species and the breed and the dog's name. Now the setSpecies function, remember, is all the way back here in the animal class. Here it is, setSpecies. And that's okay. This is public. Just because the class is abstract, that's okay. We can get at this code. We want the code. We just don't want to ever make a new animal. we want to make a new MyDog. This is the one that's not abstract. So we're setting the breed, which is in the dog class, setting the dog name, which is in this class. Set dog name. And we have a function to show the dog, which again, I get the species. I'm using the technique here of getting and setting everything. I'm not accessing any of the variables in the parent classes, if you will, directly. This is more traditional. However, as you may recall from an earlier lesson, if I made those variables protected instead, I could use them in the extended classes and specify them directly without using a method to get at their value. So this is going to print out the species as a certain breed, and it's named whatever name you gave it. Over here is where we run the code. I'm making a new MyDog, dog, spaniel, woof woof. And that's in that variable is the object, and I'm going to show dog on that object. That's the instantiated class. So let's go ahead and run it. I have to replace this part with localhost. And there it is. My dog is a spaniel named Woof Woof. So I want to show you what happens when you do this wrong now. So let's go back to the code. And I have an abstract animal, wrong way 1. Let's just look from the top. Animal, and I didn't make it abstract. Class dog, not abstract. This is pretty much the same thing as I had before. I just didn't make the 2 inherited classes abstract. So I get down here and I make a new animal. And I set the species to dog. And now I'm going to run the get species on my animal, pull it back into here, and then I print out I have a generic, whatever I set. I'll go ahead and run it real quick. And replace this with localhost. I have a generic dog. That would be pretty scary, so you don't want that. You don't want a generic dog. Let's go back to the code, and I'm going to do another file here that's wrong in a different way. This time, I have it abstract animal, which is what I intended. I have the abstract dog, just as I intended. I'm trying to instantiate an animal like I did last time. Instead of instantiating properly my dog, which is not abstract, I'm trying to instantiate animal. Here's a little comment saying that this is what I'm attempting to do. Let's see what happens when I've used the abstract and I try to do this. Go run it. Change the front to localhost again. Hit the enter key. And it says cannot instantiate abstract class animal. Well, that's pretty clear. Points you to the line number over there. This will help enforce these rules and help your coding and more likely other people's coding on a team where you may be working in an object-oriented PHP environment from making this kind of mistake. It's a traffic cop thing, I like to say, to enforce rules that you want followed. This lesson is on overriding methods in object-oriented PHP. Now we know that we can inherit one class into another, and that class may have a method, and we may not like that method. We may want to do something else, but we want to call it the same thing. So we can do that. And when we call it the same thing, we override it. We say, mine counts, yours doesn't. Let's go ahead and look at some code here. First, I'm going to show you just the example where I don't override anything. So we've seen this before, an abstract animal, the get and set. I also have a function here called showTitle, and it puts a heading out called animal species. I've got a dog, an abstract dog, extending animal, and the get breed, set breed. And then my dog extending dog with the dog name. See here we have a constructor that passes in the information and sets it. Get dog name, set dog name, and now we have the show dog function, which of course is going to get the species from up the chain of command in the animal class and get the breed from the dog class, and then print out the message. So let's look at the code that executes this. It's pretty straightforward. We make a new MyDog into the variable MyDog, pass the key data. We're going to show the title. Remember the title on the very top of the food chain here? The title says animal species. I want you to pay attention to that because we're going to change it in the next example. And then show dog, which puts out this message. So let's go ahead and run this. Change this to localhost. And it says animal species. My dog is a spaniel named Woof Woof. Now let's go override something. Here in the next example, I'm going to do some overriding. This part's still the same. Animal, abstract animal class. Everything's the same. We've got the show title function in the animal class. Let's go all the way down to the my dog class. And if you look here now, I have specified a show title function, the same exact name that I used in the animal class. But this time I'm saying I want the heading to be animal species of the world. I want a longer title. So let's see if this gets overridden. We go down and our code that executes is the same as it was before. We did show title before, but the last time we executed the show title that was in the animal class. In object-oriented programming, it's going to recognize that the last show title in the food chain, in the inheritance chain, is going to win. So let's go ahead and run it. Change this to localhost. Animal species of the world. It clobbered the show title function that was in the animal class and just treated it as if it wasn't there, completely overriding it. I'm going to show you something where I deal with the parent. I don't throw away all of the code that is in the method that I've overridden, but I execute the code and then I extend it. So this is the animal class, and we have a getSpecies function there, just like we did before. Pretty much just returns whatever has been stored in the species variable. This time, I'm going to extend that. I'm going to go all the way down the code to the MyDog class, and then down a little farther, where I have my own getSpecies function. If I just left that alone and wrote something else out, it would completely clobber it. So what I want to do now is I want to run what's on the parent, what is in the animal getSpecies method. And this is the way to specify it. So you run that method, pull back the species that was stored there, and now I'm going to extend it a little bit. I'm going to say the species name, and I'm going to write out the word species, which I didn't do before. So I'm extending the functionality on the getSpecies method that was defined in the animal class. I'm doing this, of course, in the MyDog class that is in the bottom of the inheritance chain. The code here is pretty much the same we had before, although I'm not showing title. So I get the MyDog, pass the data, and then do showDog. So let's run it. Localhost. My dog species is a spaniel named Woof Woof. That doesn't really make a lot of sense, but I wanted to show you how this could be done, how you could keep the functionality of a method you wanted to override and then extend it. This lesson is on using the final keyword on a class or a method in object-oriented PHP. Before I show you some code that I've developed, I want to just bring you to a site that I like to remind people of. This is php.net. And there is information about classes and objects and object-oriented programming in general. Here's some information on the final keyword. Essentially, it prevents a method from being overridden. When you say something is final, as I have here, final public function, more testing, you are not allowed to override it. Down here, if one tries to override it, you'll get a fatal error, cannot override final method. And here you can actually put the word final in front of a class as well. And if you do that, that class cannot be extended. You're either going to use it in a static way for some other functionality and you just want to call methods directly off the class. You don't want it extended somewhere. You can have any reason, but you will get a fatal error. Here you see that this is a final class, base class, and here the child class tries to extend base class. It says here that you'll get a fatal error. So I highly recommend using php.net to look things up. There are often very good examples provided by people like you and I who go in and put examples in there. Let's go to some code. Now this one, I'm just going to show the method. Now in this case, I have an animal, show type method, and here I have final function show animal. I put the final over there. I'll put it in front as shown in the other example. I've got final public function show animal, and then I've got dog extending animal. I can extend a class if the class is not final, but it does have a final method in there or function. We can do that. I just can't override it. So it's called show animal, and I haven't overridden it here. I'm just going to call it. So let's try that first, where I do things correctly. And we'll put in localhost here. Hit the enter key. This is a dog type of animal. This dog is named Lassie. I'll go back to the code again. And now I'm going to do it where I make a mistake. Again, I have this final function, show animal. Put it over here just to keep it consistent. Then I'll go down, and now I'm going to try to override the show animal method. And I want to put the word, this is a great dog type of animal. I want to put the word great in there and see what happens. So we will try to run this, bring it up, cancel, and override with localhost. Enter. It says cannot override final method animal, show animal. Once you say final, that's it, it's final. So as I mentioned earlier, a lot of things in object-oriented programming are designed to enforce rules. I call it a traffic cop. Essentially, it's the police that says, I don't want you changing this in any way. This is final. Don't change it. If you want to do something different, write a brand new method. We are expecting in this application to have this method always be called that, always have this many arguments, and the expectation among team members is that it will be there and behave in the same way and never change. This lesson is on defining and implementing interfaces in PHP. Now, for the first time, we're going to make something that's not a class. We're going to define a structure in something called an interface. So I want to show you with code how this behaves and what it's useful for. Come over to this first file. This is in your working files, chapter 3 area. It's employee_work_1.php. So we start off with a person, class of person. It's got a first name and a last name. We've got a get and a set function. Standard stuff. Now we have two interfaces defined. So we use the keyword interface, not class. Now, interfaces have two main purposes in object-oriented life. One is to define constants that can be used with another class, in fact, with many classes. Because we're not going to extend job codes, we're going to implement job codes. That's the key word. It makes it different than a class. So I've got these three constants here: payroll, manager, retail. And these are what they're equal to. When I see this constant, I'm really looking at a string that is 0, 1. Now, for those of you who know other object-oriented languages, a constant in PHP is very much like a final static in Java. I've got these set of constants. Now, the nice thing about an interface is I can implement them anywhere. One of the rules of PHP's version of object-oriented programming is I can only extend one class. Let's look down here. Class employee extends person. If this job codes was not an interface and was a class instead, I could not say class employee extends person, comma, job codes, or extends job codes too. I couldn't say anything. You can only extend one class at a time. You can make it go down as much as you want. As you've seen before, we had dog extending animal, my dog extending dog, and you could take that as far as it logically needed to go. You just can't get two classes to go into one class at any one time. But interfaces help solve some of this problem. You can implement as many interfaces as are useful. For example, I have down here in class employee. It extends person, but it implements job codes and standard functions, which is the other interface right here. Now let's look at those. This is the other use for an interface. Is we list functions. While I don't specify the word abstract, that's what these are. You just don't put it in there. They're abstract because they don't do anything. Look at this. Public function, get a job title, and it passes in some data. And it's got a semicolon. Same thing with the show full name function. Has to be public. Doesn't do anything. So why would I bother putting these function names in here, whether they have data passed to them or not? The idea is this is a enforcing mechanism. We're enforcing consistency across the application. If you're coding by yourself, writing a small little app, you may not need to use this. But if you're working on a team with many people doing object-oriented PHP, you may want to enforce that a method name to get a job title is always called getJobTitle. If you leave it to all individual developers, it might be capital J and a small t in some methods, and vice versa. This way, you have a consistent name. If you require every class that makes sense to implement the standard functions, you're going to get consistency in naming. Whenever you implement an interface that has an abstract function defined this way, you have made a contract with that interface that you must override that function. You don't have a choice. You can't just override getJobTitle because I need that, but I'm not going to use show full name because I don't need that here. You don't get a choice. You must override that function if you implement the interface. So as we see down here, employee extends person, implements job codes, standard function. So now I have to have a getJobTitle and a show full name down here. And I do. I want to show you something though. Look, I've got them there. Open bracket, close curly brace, nothing. They still don't do anything. But this meets the minimum requirement for the object-oriented PHP compiler. So it won't crash on me. I won't get an error. Now, this is not terribly useful. It wouldn't make a whole lot of sense to implement an interface that had functions in it if you didn't want to put code in at least one of the functions. But just to show you that this would work, I put it in this way as a first pass. Next, I'll show you something with code filled in. I'm creating a new employee, name, employee ID, and a number that represents my job code. And then I'm getting the full name and putting over here and just saying hi full name. So let's go ahead and run this real quick. And we'll go over here, change that to localhost. Hi, Steve Perry. Good enough. Go back to the code here, and I'm going to use another file. This is the employee works 2. Same thing I had before. Same job code, same standard functions. However, down here, get job title, job code, I've put some code in it. I'm going to have it do something. What it's doing here is it's checking what is passed in, the job code, versus one of my constants. I have to say self : because a constant is treated as a static. So you say self : payroll. Am I a payroll? Then my job title becomes payroll clerk. Am I a manager? Job title becomes manager. If I'm a retail, my job title is retail clerk. And that's what it was set in. It was set as 3. At the end, I just return job title. Show full name is getting the full name, putting it in there and saying hi full name. Let's look at this. New employee, just like we had before, Steve Perry. Job code for the retail clerk, show full name. And then I have get job title. And I'm going to show the job title as well. Put it over here, and then I'm going to print out that your job title is what was returned from this get job title when I passed in 03. Let's give this a try. We'll change that to localhost. Hi, Steve Perry. Your job title is retail clerk. I want to show you a file here where I forget to put in those names for functions that are implemented in the standard functions. I have the same 2 interfaces. Here's the standard functions. It's being implemented, standard functions in the employee, but I don't put the method names in here at all, not even with empty code. So let's try to run this and see what we get. Cancel there, change to localhost, hit the enter key. Fatal error. Class employee contains 2 abstract methods. Remember, those public functions that we defined in that interface are considered abstract methods. You don't specify the word abstract. They just are abstract. And therefore, must be declared abstract or implement the remaining methods in get job title and show full name. So it's telling us I'm expecting to see those implemented, and they're not. This lesson is on using the object-oriented style when dealing with MySQLi functions in PHP. As I looked around at coding examples in PHP, I noticed that many of them use this object-oriented way of dealing with MySQLi. If you've taken my last class here at Infinite Skills, Dynamic Web Design using PHP and MySQL, you will have seen the MySQLi functions demonstrated. Let's go ahead and look at some code here. I'm going to show you how it's done in an object-oriented fashion. I'm going to run this first. Replace the front part with localhost. This, by the way, is called OOP and MySQLi PHP, and it's in your Chapter 3 area of your working files. This just puts all the authors who live in California. It's going against a database that I've set up here locally, and it's going against the author table and just showing the last name, first name, and state, and then giving a total at the end. So let's look at the code now. Standard stuff here. See the keyword new here. When you're looking at examples online of PHP, often people set it up this way. They create an actual new MySQLi object. And it's set up the same way if you use the standard MySQLi connect function. New object, localhost, the user, and the password, which is empty, and I'm just using the test database. So you ask the question, is MySQLi, this is what I called it here. In some examples, I use $db instead. But you'll see both on the internet, so I chose to use this methodology. So if not, mainly it's false, the object wasn't created correctly, then we did not make a good connection. So moving on, we see this SQL statement. It's a select of last name, first name, and state from the author table. And I'm using the where clause where state equals California, and I'm ordering the list by last name and first name. So let's come down here. Now instead of the MySQLi query, we run a query method as part of the MySQLi object that was created. Pass to it the SQL statement. It's very similar. It just uses the little arrow and it puts it this way. I don't want you to be blown away if you see this out on other people's code and wondered why we didn't talk about it in object-oriented programming. But it's here. When it comes back, you return a result, very much like you do when you do MySQLi query in a procedural way. So if the result is not good, if it came back false, we put out an error message. Now look, this is different too. We say off the object, MySQLi, we show the error no, or we show the error, which is the error message. Over here we have another one, MySQLi object, little arrow, affected rows. So if there were rows changed as a result of this, we can see that. Here's what we saw. It ran successfully. We got the heading, authors who live in California. Started a table of last name, first name, and state. The headings are there. To get the number of rows that were returned as part of the result, I look at the $result as if it were an object. It is an object the way it's returned. And I use the little arrow to get at num_rows. So that's how many rows came back in the results for my select. That is handy when making a for loop, as we can go through it the num results number of times for the number of rows. I have a little routine here to change the background display of a row so it alternates. To get individual row in the result set, again, we look at the result object, put an arrow, and we do fetch association. And that way, it's done in an abbreviated sense, and it pulls back the $row. We're going to get the information off the row in a similar fashion. We're going to just pass the column name, get the last name, the first name, get the first name into a variable, same with the state. And then we're just outputting this information into a row of a table. After the loop is done, I end the table, and voila, pretty much done. Just at the very end of the program, I'm showing the number of rows in the results, and I maintained my own row count, although I could have used the num results that came back as well. Then we print it all out. This presentation is on the Assignment 2 requirements. So I'm going to show you the application as I've written it before we move on and look at the requirements. I think it'll be easier to get a sense of where you need to go if you see the application working first. I've coded the application, got it to work. And what the goal here is we add one transaction at a time. We've got 4 fields here, income and expense, item, category, and amount. And then there's a submit button here that has a value of add transaction. So we see that displayed there. Below here, we have the beginning of an HTML table. Those are the titles of the data we're going to show. But right now, there's no rows on it. As we add a transaction, we want it to appear as a row in the HTML table. Let's give this a whirl. I'll pick an expense. And now I'll do apples. And I'll say that's food. And I'm going to spend $22. I click on the Add Transaction Submit button. And there it is. Apples, food, 22. Now I'm going to add income, which I'm going to say rent as income. I'll go ahead and I'll pick rent as a category. And I'll put in $1,200. Now I click the Add Transaction button. This time it says rent is not a valid category. What that really means is rent is not a valid category for income. It is a valid category for expense. Go ahead and enter it now as an expense. I'll put in rent, and I'll put in $1,200 again, and I'll now click it. And this time we get it in there. So that's how the application should behave. Now we'll go ahead and look at the requirements. So here are the general requirements for assignment 2. We're going to create a financial transaction HTML form, and it allows the user to select either the income or expense from a select option list, enter an item name for the transaction, and then you can also select from a select option list the valid categories. They're food, gas, paycheck, rent, and stock. You enter an amount for the transaction, and then you click a Submit button to add a transaction. And we named it Add Transaction by setting the value property on the Submit button. After it adds it, we are going to display a list of all current known transactions in a table below the HTML form. Let's look at the structure of the program. Now we're going to have two interfaces, income categories and expense categories. Now they have some similarities. Each one of them is going to define constants, but in the income categories interface, we'll define constants that describe valid categories for income transactions. Those are paycheck and stock. Likewise, for expense categories, it'll be rent, food, and gas. Now, the other thing that these interfaces will do is define a method definition. It'll be check income category on the income categories interface and check expense category on the expense categories interface. Each one of those is going to receive the category that a user enters as the argument. Let's go on and look at the transaction class. It is at the top of the inheritance chain, and it should not be allowed to be instantiated by itself. You may recall that Object-Oriented PHP has a construct to prevent that from being instantiated. It has the following instance variables: item, category, and amount. It has a display transaction function, or as I've abbreviated here, display trans, which will read from the transfile.txt file and display information that's stored in each line of that file as a row in the HTML table. The function can be called directly from the transaction class. The format that the transfile text file stores the data in is a delimited string. It's delimited by an asterisk. It's going to hold the income expense indicator, the item name, category, and amount. It will look something like this. I might have income, asterisk, dividends, asterisk, stock, asterisk, 222 for the amount, and then put an asterisk at the end of all that. And of course, when you write a file in PHP, you want to put a new line character in there, a \n. The other function it has is an add trans function, which appends a transaction to the transfile.txt file in the delimited string format that I just showed you above. Let's look at the income class now. So the income tran class will inherit the transaction class and implement the income categories interface. The check income category method will check the income category that was selected by the user against the list of valid income categories defined in the income categories interface. The expense tran class will also inherit the transaction class, but it will implement the expense categories interface. And the check expense category method there will check the expense category selected by the user against the list of valid expense categories defined in the expense categories interface. Moving on, let's now talk about the processing. The Submit button, that's the Add Transaction button, when clicked, will recursively call the program and do the following. Displays the HTML form, determine if this is the first time the HTML form is displaying for the user to enter data, and if so, it'll display a list of the current known transactions in a table below the HTML form and then end the processing. Now, if a user has entered data to be processed, do the following. If the user selected income as the type of transaction, instantiate an income tran object and check to see if the category selected is valid for an income transaction. If the user selected expense as the type of transaction, instantiate an expense tran object to see if the category selected is valid for the expense transaction. If the category is valid for the income expense type, then add the data as a line in the trans file text file. Otherwise, display an error message. The last thing you need to do is always at the very end of the processing, display a list of the current known transactions in the table below the HTML form. This ends the presentation on Assignment 2 requirements. These are contained in the Assignment 2 requirements.html file that you'll find in Chapter 3 of your working files. This presentation is on the solution to Assignment 2. Just to remind you, this is what Assignment 2 looked like. I entered categories. If I put an income category in there and I put something in wrong, apples, I'm going to say rent because rent's not an income category, and I go ahead and put in 222. I'll add the transaction and it says rent is not a valid category and it does not put it in there. It actually is not a valid category for income. It is a valid category for expense. So that's the key thing. We're going to discern if they've selected an appropriate category for the type, income or expense. So let's look at code. Here we are, top of a form. So I've got a name form 1. I am doing this recursively. So I've put this in the action tag, the server PHP self. So it'll come back and rerun itself every time we hit the submit button. Come back to the top. So it'll display the form. Here's the select option list with income and expense. The name of the item that we can enter. It's just an input. And now another select option list, which is for the category. I put a hyphen in the beginning just to force the user to select something. Food, gas, paycheck, rent, stock. And then the input area for the amount. And then the submit button. Name submit me. And it's called add transaction. And there were the headings. Here's the horizontal rule and the beginning of the table that you saw. So the heading of the table. Here, the headings on top of each column that you're going to fill in. Interfaces. You need an interface. Income categories. I can't put arrays in here the way I can in Java. I don't have an object that I can put in as a constant. Remember that a constant, for those of you proficient in other object-oriented languages, is a static final or final static. So I have income cats, stock, asterisk, paycheck, asterisk. So I'm using a delimited string again. And I'm going to use that to process whether they entered the right kind of category for income. Now we have a function called check income category where we're passing the category to it. That is an abstract function. I'm going to have to fill in the details later. Expense categories. And here, same kind of thing, rent, food, gas, delimited string, and check expense category. So here's the granddaddy class. This is an abstract class. That's what I was hoping you would get when I said that this cannot be implemented on its own. We have protected variables here, amount, category, item. A constructor that's going to build that and set those values based on what's passed in when we make a new one. C item, C category, C amount. I have a static function I implied in the requirements that the display trans can be called directly from the class. So we can do transaction : display trans. It's not something we have to instantiate the transaction or something that inherits from transaction to get at this. We can just get at it directly. All it is really doing is setting up a file name, which I call transfile.txt, checking to see if it exists. If it does, it reads from it. This is just a little coding trick that I use. Some people will probably hate it, but I put while true in there. So that means it's an infinite loop. It'll run forever. So I've got to catch something in here to stop that loop. And what I do is I look at the end of file. Since I'm reading a file with the fgets, that's the file pointer that was gotten here by the fopen over here. If I get to the end of the file, I return out of here. So that gets me out of this function. I get a line of data into $line. Now here's the key thing. Look to the right side of the equal sign first. I explode the line on an asterisk. That basically means break it up on the asterisk and divide it into its subparts. Now I can return it directly as an array, but since I know where things are going to go, I can use the list function here and return it directly into variable names that I'm going to use. The A income expense, A item, A category, A amount. Those are the ones that I'm going to put inside the table for displaying. This is, again, the display transactions function, so it's just going to put this stuff in a table so we can see what we have already. And then we close the file and we're done. Okay, another function on the transaction file is the add trans. I'm going to pass in whether it's an income or expense item. If it's an income or expense, I'm going to write out in this $tran area, I'm building up a delimited string. So I've got the income or expense, asterisk. I've got the item, asterisk, the category, asterisk, the amount, asterisk. And then it's very important to put this \n in there so we get a new line feed. And that way, each time we run the add trans, we're writing it on a new line in the file. So there's the trans file name again in the file name. I open the file name, this time for append, because I don't want to lose any data that was already there. I want to append a new line onto the file always. Once I have it there, I have a pointer to the file. I write to the file. I write whatever I had in tran up there. And then I close the file, because when I add trans, I just add one trans at a time. Every time they click the button, they add a trans. Moving down the show here, income tran. It extends transaction and implements income categories. Since I put the function I needed and the constants I needed in one interface, I just have to implement one interface. Private tran type is income. Now the function, check income category. Since I'm now in a class here, class income item, and I've implemented income categories, I am required to define this function. As I mentioned when we covered interfaces, I don't have to put anything in there to get it to compile, but I want to put something in there because I want it to check for the validity of the categories. Remember, we get self income cats because those constants are static. So I'm going to pull that variable back. I'm going to explode it. Remember, I divided it up by an asterisk. So I'm going to take all those categories. Let's go back and take a quick look. Income categories is all the way at the top. I have stock and paycheck. So I'm dividing that up and I'm going to pull it into an array this time because I want to use the array to check. Let's go back down to income. So I pull this back and explode. And this time I don't use list. I just pull it into a variable, which is an array, valid categories. So now I'm going to use this array to see if I have any valid categories for the income because I brought back income cats. To start things off, I set a Boolean up, $is valid, to be false. And then I'm going to go through a loop and check the category that I have here against the ones that are valid. And if any one of them becomes valid in this loop, I'll set the isValid equal to true. And at the end, I'll return isValid. And then if it ever became valid, I got a true there and it'll go on its merry way and report true. It's a good category. Otherwise, it'll be the default of false, that it was not. I'm using a for each, so I go through every element of this array, and I just called it $element. So if $element equals the category that was passed in, check income category, then I get the true. It is valid. I'm doing exactly the same kind of thing with the expense tran class. I extend transaction. I implement, in this case, expense categories. I'm looking at the expense cats, not income cats, doing the loop and the is valid is false. The same logic, just different set of categories. I'm looking at the button, see if the button exists. If it does exist, that means the form is fully instantiated and I'm ready to accept data from the user, the data's been clicked, and we can move on. But if that is not instantiated in the form yet, I'm just going to make the button be equal to an empty space, and I'm going to call the display trans function, the one that reads the file and shows the data for transactions on the opening of the page. Notice the colon. It's right on the class name, capital letter, that's the key, and it runs that function. So I can run in a static way. I don't need to instantiate anything. If the button's clicked, the button will be equal to add transaction. That's what I put in the value. And so I'm going to go ahead and post. I'm going to get all these items that were entered or selected by the user, selected. I'm making is valid false. And then I come down here and I'm going to say, well, did they select income? So if they selected income, I'm going to instantiate a new income tran with the other information, the item, the category, and the amount. And I'll put that in $myTransaction. So that's my object based on this class definition. Then this is where I run check income category and the category that they entered. That's the post category they entered or they selected, really. It comes back and it runs it off the object and returns whether it's valid or not. I do the same thing with expense. If it's equal to expense, I go ahead and make an expense tran. I run the check expense category, etc. The reason for the else here is I had a hyphen they could pick. So if they didn't pick income or expense, they would say, please select income or expense. So that was one validation that was on there. At the very end, all we got to do is it valid or is it not? If it is valid, this is a shortcut way of saying if $is valid equal true, you can just do it like this and it'll assume true. And if it is true, I'll run the add transaction and I'll put this information as a line in the transaction file. And remember it, this add trans is coming off the object. Otherwise, I print this error message and I don't run the thing that's going to add another transaction. I do always display the trans at the end of the file, no matter what. That ends the presentation on how to solve this problem. We are at the end of class, and I've gone through everything that I'm going to show you here, so what's next? One of the main things that I recommend people do, not just with Object-Oriented PHP, but with any software that you're learning, if you really want to retain that knowledge, find a way to use it for something. Hopefully something that's useful, but frankly, even something that isn't useful, just build something new that requires you to think about how you would apply these concepts in a way that could be useful. Look for jobs. There are jobs out there, freelance jobs, obviously main jobs if that's what you're looking for. If you look on various websites, look for the words object-oriented with PHP, or sometimes it's OOP PHP for object-oriented programming, and look for that. The one concept here, on the second bullet that I didn't cover, was something called polymorphism. PHP does implement this concept in a limited way. There's information, if you do a Google search on it, you'll find various pages and examples. It's not as good as some of the other languages like Java and C++, but if you really do need it, that's something that you should research further. A third thing here is to consider using static properties and functions more often. When we are coming from procedural PHP and learning about object-oriented, it can be a bit overwhelming. We're instantiating objects all over the place and using these rules to get things on that object and so forth, and that is a very useful thing about object-oriented programming. But in a classroom situation, we do more of it than you probably need to do in real life with most applications. I found that if something doesn't need to be an object, if it can just be code on a class, that's a way to organize it, I can just make it static and call it on the class name. So think about whether you really do need to instantiate a class or not. And if you don't, have everything be static and just use it that way. So what's the advantage then to object-oriented programming? It is usually avoiding naming conflicts with other functions and variables. This can happen if you're working on a very large application, but more often than not, it implies that you're working on a team. You're working with other people on an application. And this gives us a way to kind of enforce a prefixing, if you will, of a function and a variable with the object name. Makes it much less likely of stepping on each other's toes, overwriting each other's code, or causing conflicts. This ends the class and the presentation. I hope you've enjoyed it.